Welcome back to another Web Dev Podcast episode where we help aspiring developers get jobs and junior developers grow. In this episode, we are going to be tackling the very tough subject of how the heck do we learn data structures and algorithms? There are a lot of very strong opinions on Reddit from different developers, and I decided to bring on Matt, who actually has quite extensive experience training software engineers and aspiring software engineers into even positions that big tech positions where it's maybe a little bit more leak code heavy, but he's trained a lot of people and he'll talk more about that. But yeah, I just brought someone on to, clarify how people can navigate this messy world of data structures and algorithms, how we can get started. And yeah, let's just dive into things. Matt, I appreciate you coming on, but yeah, do a little intro for yourself. Who are you?
Yeah, thanks. My name's Matt. I go by Coach Matt, and there's been a motif of like mentoring, teaching throughout my entire life, and that's manifested in my work as well. So I've been working for 10 years. First month of my professional work experience, I was interviewing people. I really enjoyed it for whatever reason. I've been doing a lot of real interviews since then, and mock interviews. I worked with a boot camp where I was working on all their content, their tech-related content. And in terms of the interview process, I've really seen it from every angle. So I've applied as an individual contributor. I've applied as a manager. I have hired people as a hiring manager. I've interviewed people as an individual contributor. I have fired people, and I've been fired myself one time. So, okay, yeah, a lot of experiences around that, and I think that really helps me in my mentorship, my coaching.
Love it. I appreciate the transparency. Not a lot of people are willing to say that. I've definitely been fired before as well, and I'm sure other people have. So actually, yeah, I dig that. So let's actually just dive into it, because I'm very confident with what you know. I've talked to you before, but the big question really is, like, as a new developer, like, my audience full of new developers, junior developers, it's very difficult to like really solidify how to get started, when to implement data structures and algorithms, and how to navigate through that, and how to measure your progress. And then, like, if you do get stuck, you do hit a plateau, where the hell do I go from here, right? So we're going to dive into all that, but yeah, let's just get started. If you had to give advice for like how to get started with it, what would you usually recommend people?
Yeah, great question. How do you get started with getting started, pretty much? Right. Well, the number one mistake that I see a really common mistake that I see people making is that they're trying stuff that's too challenging. So I like to think of it as levels of understanding. So imagine when you're speaking a language, first you learn that's a little bit backwards, because you learn words and then you learn to spell. But imagine you learn to spell and then you learn words and then you learn to make sentences and then write paragraphs and maybe stories if you go that far. Right. So I think this translates quite well to programming. So first you would learn syntax, and then I would say native data structures and how to work with those. And then you learn concepts. A concept could be recursion, or depth first traversal on a binary tree, or dynamic programming. Dynamic programming is essentially recursion with memoization, and memoization is caching without cache invalidation. So like there's this really graph of concepts and how they relate to each other, and that's what I see as the fundamental language behind algorithms. And when you introduced the idea of this chat to me, you use this DSA acronym, which is something that I've seen a few times and I had forgotten about because I use it so infrequently. It's the right one to use, but for me, find it a little bit awkward because I see data structures and algorithms as nearly synonymous with programming. right? So data structures is really anything beyond a primitive, so some structure of data, and an algorithm is essentially any function. So you write functions that work with data. That is programming. So, yeah,
I really like how you broke that down.
That's how I like to teach. I like to identify, the fundamentals and build up from there. Especially identifying, where the missing gaps are in the person's knowledge, because everyone, right, this day and age, people are teaching themselves. Everyone has like a different background, different experiences, different aptitudes. So people get caught up on different things. People, maybe even don't hear about certain concepts. So, yeah.
Okay. So the way you're describing it, the way you've simplified essentially what it is, it's much less intimidating to just see it as data and a function that does something with that data. It's much less intimidating. But in junior developers' minds, they hear you must learn data structures and algorithms. And there's a reputation for how in-depth this can be. And it starts to go into a little bit more obscure leak code problem area where you might never use these types of, or you might never need to know these types of solutions or be able to solve certain types of problems or have to memorize a certain algorithm or a search algorithm, right? So people in their mind, they kind of create this like boogeyman and this monster that is so intimidating. They're never going to be able to defeat that monster. Like I know I'm being really silly with this, but I'm telling you, like a lot of junior developers like have this vision. So I guess help me understand, or for those that are kind of like creating that vision, what's a more realistic end goal with learning data structures and algorithms that's reachable? Do they have to go deep into this well of tons of elite code problems to stand out among employers? Do a lot of employers test for this? Or what do employers, like when they hear that employers are going to test you with coding challenges and DSA problems, like how deep do they go and what are they really looking for? Let's start with that.
Yeah, that's a great question. So what are they looking for? I'll start with that. Especially for people that are starting out in the industry, they want to know that you can solve problems, ideally difficult problems. And the industry has settled on, and I largely agree with this, the coding algorithm interview format. So that's really what we've arrived on. And as in terms of feeling overwhelmed by the wealth, the breadth, that's breadth first search. That's another concept. The breadth of algorithms out there. I think LeetCode is at fault here in terms of presenting this, multi-thousand, I believe, list of questions, which is really hard to navigate. It's incredibly intimidating. And the metadata that you have around that is primarily like difficulty, and that's even low resolution. It's like easy, medium, hard. It's really hard to figure out what do I work on and when, how much of this do I need to know, right? There's like the blind 75, and there's another one that's really popular too that are just, consolidated lists of LeetCode, which helps. But I like to think about it back the other way again. So going back to the levels of complexity that we were talking about, syntax, and then working with native data structures, and then concepts, and then algorithms. The concepts and algorithms can really be kind of like a chicken and egg thing. So you can work on an algorithm, but first be aware of the concepts that are required to solve that algorithm. And then to exercise that a little bit more, you can find more algorithms that exercise those same concepts. So I think that's the way to go. And you really want to focus on learning these concepts, which will allow you to, instead of, say, if you're given the really common algorithm of counting the number of islands in a matrix. So you have a two-dimensional matrix where 1 represents land and 0 represents water. You want to find the number of, contiguous blobs in that in that matrix. So if you're not aware of the concepts or familiar enough with the concepts at play here, you might say, well, I need to create an array and, loop through the matrix. And then whenever I find one, I need to look at all the neighbors, but then make sure I don't revisit. There's a lot of complexity there, but you could really boil that down into like, it's a depth first search over the matrix space. Each time you find a new piece of land, you do the depth first search, mark all that is visited, and that's the algorithm. So if you are familiar with these concepts and you focus on the concepts primarily, then the algorithms become compositions of those concepts. And I mean, that's essentially like how we write. That's capturing how we write code in the real world too, right? We have these separation of concerns, these abstractions that we rely upon. You can't keep every line of code within a project on the within your head at one time. It's just too much. So you need these abstractions. You need these higher levels of abstraction. You need this higher language to break down these problems and go about solving them.
Makes sense.
Yeah,
I feel like yeah, the question still remains. So you mentioned like the algorithm, the solution was a depth first search,
right?
And even the idea, like when you said it, it felt very obvious. But even the idea of like, if someone else hears it, like depth first search, okay, I've never heard of that before. When am I supposed to learn it, right? Is there a way where, I guess, this is my question. Is there a way where when people are working on their personal projects and they are starting to reinforce skills or doing more challenges, how do people figure out this like natural transition to apply these concepts in a very practical way? Do they just look up challenges on the internet? Should they use ChatGPT to help generate challenges? Should they integrate, build a feature or something that's going to have to utilize data in a certain way with their personal project to apply a more complex algorithm or utilize a more complex data structure? Because I still feel like there's that bridge that I think people still struggle with. And yeah, I was hoping you can clarify that.
Yeah. So how does this translate to working on real projects?
Yeah.
So I want to put a pin in ChatGPT.
Okay.
ChatGPT is really interesting. It's a fantastic tool to prototype with. I did a session with someone who's really high up in Amazon and switching to a more technical role, and she doesn't have the technical background. And I suggested using chat. You can be in a place where you're so confused by what's at play, like you have difficulty formulating proper questions, right? I think ChatGPT is a great tool to ask it, air quotes, silly questions, and then have it help you have a dialogue with that. ChatGPT is always there; it's on demand. A dialogue there to explore and get a better understanding of what's going on there. A better solution would be to work with a mentor or peer or someone. So how does this translate to practical projects? So, well, first of all, I think it's really difficult to derive these, difficult, near impossible to derive these concepts if you're not aware of them in the first place. So you have to learn whatever concepts are going to be necessary for the project. Really, there aren't a massive amount of these concepts that are used. So I think what you want to do is really just build up a routine of working on algorithms every day. They don't even need to be very difficult algorithms. Actually, I even break down algorithms along two axes, where one is the difficulty and the other one is the the complexity. And by that, I mean like how difficult the code is to understand. Like correlates basically with how much code there is. You can imagine a solution that has a lot of code, but is still, pretty straightforward. So those aren't the same thing exactly. So I think it's very beneficial to work on these simple, but potentially, easier, moderate difficulty algorithms every day. On my website, I actually have questions mapped along those axes, as well as each of those algorithms maps to the concepts at play. And then those concepts have pages that explain what they are and map to other algorithms that leverage that concept. So the whole self-teaching process that I was saying of pick a concept, learn the concept, practice it with an algo, find more algos, right? That's all very natural on this platform. But once you have that familiarity, then those are tools. Those are larger things that you can reason about when you're working on a project. So I think that's you have to learn the stuff and then bring it into your practical coding.
Okay.
You can't really go backwards.
Yeah, that makes sense. So get exposure initially to some of the data structures and algorithms. And you mentioned this idea of like you find that many people will just dive too deep too quickly.
Yes.
How do you know if you're diving too deep too quickly, and how do you know if it's like the appropriate challenge?
Yeah, that's a really awesome question. If you feel like you're beating your head against the wall, so this is something where ideally similar or more experienced peers that can help you out. I saw this happen. I've seen this happen so many times, say with web front-end engineers that are working in React. So there's a lot of moving pieces there. Say if you're trying to write something in React, you have potentially inline CSS, you have HTML and JSX, which isn't quite HTML, but it mostly is. And you, of course, have JavaScript, right? There's a lot of moving pieces there. And, some people even really get tripped up with all the syntax at play there. So for people at that level, I think a good litmus test is to see if you can write a React function that renders a two-dimensional grid of cells. So a lot of moving pieces there. If you do know everything you need to know to do that, it might feel a little awkward, and admittedly it is. And if you have no idea what to do, then you need to take a step back and familiarize yourself with whatever syntax or moving pieces are fuzzy. Did I miss anything with your question?
I think that's helpful. For people that aren't really familiar or used to diving into a little bit more complex coding challenges, you provided the example of like, yes, people dive too deeply into React too quickly, very, very often. Like that's a very common problem. And so I think that's the difficulty. It's like, it's knowing when to dive into the next advanced concept. You mentioned the idea of like, if you're beating your head on the wall, is there like, let's actually break this down a little bit more. Is there a time limit you would give someone where they haven't made any forward momentum with a problem, where you would suggest that maybe they need to take a step back? Do you have any like timelines like that?
I'm not sure if I would come up with an explicit time. I think it's more of a feeling. Like when you're coding and you recognize this is a difficult problem, maybe you're working on a really difficult problem and you're perhaps refactoring something or thinking of a new approach, and you're making like some kind of incremental progress. When you're just staring at the screen, you don't know what to write. You don't really know what to search. You don't know what concepts are at play. You don't know why you're getting a certain error. That is, to me, like beating your head against the wall. Like this feels like some futile exercise. I could work on this for another 3 hours and be exactly where I am right now. Is that yeah?
Yeah, no. What you're saying makes sense to me. I think a lot of people are, especially newer developers, are going through imposter syndrome. And I just remember like thinking back to even when I was in a coding boot camp, I literally could have like the anxiety of solving a problem on the spot, cloud my perception of if I am making progress. Like even where I might make a little incremental progress, it just felt like, am I really making progress, or should I just like, am I tackling too hard of a challenge? So I do agree with you. You kind of have to feel it out. And I would almost argue like you're going to get a better sense of that as you code more, as you program more and challenge yourself. You're going to realize how you identify roadblocks and how you identify that they actually are roadblocks and not just something that you have to overcome, and or if you have to move back in a simpler concept. So no, I like what you said. I think that makes sense. And I would just kind of encourage people to like give it time. The more you code, the more you're going to be able to assess that, I think, properly. So
can I add a few more?
Oh yeah, go for it.
So I think I can actually add a upper time limit when we're talking about algorithms. So practice algorithms will usually have an associated time frame for that. So I would respect that. Maybe, if you feel like this is all really new to you, you could, 2x that. But if you're spending more time than that, then you're going to get diminishing returns in terms of like the value of you trying to work on that problem. If you're having difficulty, then I would identify what those concepts are at play in that algorithm, find easier algorithms that stress those concepts, or read up on those concepts, do something else, and then maybe come back to it.
How do you identify those concepts?
Yeah, so that's the tricky thing. So my site has that mapped out. It's like you can't really derive a concept that you're not. It's incredibly hard to derive some concept that you're not familiar with. So you can recognize the concepts if you are familiar with them. But in terms of that derivation, that's, I think, when you need to work with, a peer or look up additional resources.
Okay. Yeah, that makes sense. How do you think there's, okay, I guess I'm going to ask two questions. One, and I know, I think it's kind of challenging your paradigm, and I think the way I'm asking it probably isn't the way that you necessarily should think about it. So feel free to challenge the way I'm asking these questions. But I think a lot of people they want to get a solidified version of exactly what they need to know, where they're going to be fairly competitive in the interviews. They're going to be able to tackle the challenges that employers give them. Would you say there's like a fundamental list of like data structures and algorithms where people should be familiar with, where a lot of you can kind of expect that a lot of companies are going to touch on one of these?
I would, yeah. So there are lists out there. I have my own, and I think just for completeness, perhaps I could just run through it. It's I think a little over 20 concepts right now. So for the ones that I think warrant additional explanation, I'll do that. So values versus references. This is something that trips people up a lot in JavaScript. So you can look that up. Truthiness. This one's quite simple, but shows up a lot. So the number 1 is a truthy value, and the empty string is a falsy value. So in JavaScript, say if you have an if statement, anything inside of that parentheses, it just cares about the truthiness of that. It doesn't care if it's literally the value true or literally the value false. So like if parentheses 0, that if statement is not going to execute. So understanding that is really important. Fortunately, it's also really simple. Actually, I think a lot of these concepts on their own are simple, and really just the complexity arises when you put them together and put it into practice. So a closure, that's essentially the extra variables that you have in the current scope and the parent scope. So if those are confusing terminology, then look it up in your own time. Data structures. So array, hash table, linked list, tree, trie, which is actually pronounced tree, but I deliberately pronounced trie to disambiguate the two. Graph, sorting, queue, stack, heap, maybe, recursion, breadth first search, depth first search, combinations and permutations. These two are quite similar. A combination is essentially a subset of a collection of elements. So if I have an array of the values 1, 2, 3, an array of just one is a combination of that. And actually combinations includes the original array. So order does not matter, but in permutations, a permutation is just a rearrangement of those values. So there's a lot of programming problems that focus on anagrams. So anagrams are, you take a word and you rearrange the letters and then you get another word. That's a permutation problem. There's a lot of permutation problems and there's a lot of combination problems. So if you recognize those two, then you can of course reuse the knowledge you already have around all of those things. Runtime complexity, caching, backtracking, which isn't as scary as it sounds, functional programming, and greediness. A greedy algorithm versus a more exhaustive search. So there's another really popular dynamic programming problem depending on the input data, which is given an amount, say a dollar amount, what is the optimal breakdown of coins to match that amount? So fortunately with the USD, our currency system, that is an algorithm that can be solved greedily. So you can just start with the biggest value that is smaller than what you have left and subtract as many of those as you can, and then go down to the next biggest coin and so on and so forth until you have no money left. That's a greedy algorithm. So this is really just going down one path. And an exhaustive search would be if there's some coin denomination that's a little more awkward, where maybe you have some coin that's worth 7 and another coin that's worth 6. So let's say you have 12. 7, 6, and 1 are the coins. So let's say you have 12 as the amount that you want to break down. If you do it greedily, you take away 7 and then you have 5 left and you need 5 ones. So that's not optimal. You could instead do 2 6 coins, if that makes sense. So greedy versus non-greedy, that's a really important one to recognize if the algorithm that you're working on can be solved greedily or not. So yeah, I think that is a very good starting point. That's like 80% of it, really, I would say.
Okay, 80%. Would you say, I appreciate you breaking that down. I mean, some of this was just a refresher for me, and I didn't know about the greedy algorithm concept even, so I appreciate you explaining that. Do you, diving into caching or learning to navigate through a graph, do you feel like, I guess I feel like that's too complicated for an entry-level developer. Do you feel like companies are testing for entry-level positions with this complex of data structures? Well,
it depends. They are, absolutely.
Okay.
Caching doesn't come up quite as much, but it is useful. There's a really popular saying that the two hardest things in computer science are caching and naming things. Caching gets particularly difficult when you're dealing with distributed systems and race conditions and things like that. And you're usually not worrying about distributed systems and race conditions if you're doing an algorithm interview, right? It's just all one machine. There's no internet connection. There's no asynchronous behavior. So caching in that sense, I think, is greatly simplified for the algorithm interview scope, usually, certainly for entry level. And then you were talking about traversal. Is that complicated? Maybe. I generally think no. If you have a data structure like a tree and a tree or a binary tree or a linked list or a graph, they're really not that useful if you can't traverse them. So if we nix traversing graphs, also just let's have some nomenclature here. A linked list and a tree are types of graphs with additional restrictions imposed. So they're all graphs. If you just nix traversing graphs, then you can't really use graphs. So these different types of graphs show up on a lot of algorithms, and traversing them.
Just to correct, I didn't mean to put the focus on the traversing part. I should have just said graphs.
Oh, graphs. Okay. Well, traversing is the most of the work that you do with the graphs. And it's just whatever you do with the data that you have at the node that you're looking at. So yeah, I think as I said before once or twice in this chat so far, the concepts on their own are usually quite simple. It's just the complexity gets introduced once you compose them together. Yeah.
Okay. What with your coaching sessions, what types of developer jobs are people typically aiming for to get that kind of help from you?
So the way I'm presenting myself online, I'm focusing on entry level. I do have some other inbound clients that are 5-10 years experience, like level 6, level 7 at FANG companies. What types of jobs are they looking for? That's a great point. So what types of jobs are they looking for, and what types of jobs should they be looking for? Those are two different things. So I've seen this quite a lot with the candidates, my clients, my mentees, whatever you want to call them, the people that I work with. Mm-hmm. They can have a tendency, right? So there's this notion that job descriptions are wish lists, and that's true to a degree, but someone that has zero work experience probably should not be applying for a job that requires 4 years of experience. And a lot of companies, especially the smaller ones that don't have their interview process ironed out as much as the bigger companies, will be more likely to pass someone with no professional work experience in the early stages of the interview. So for people that have no professional work experience and are applying for roles that are too difficult, what that often looks like for them is that they have a call, they do well in the culture fit. When they get into algorithm interviews, maybe they do well on a few of those. And at the end, they always get the same response. Oh, we went with someone else. Companies, for liability or whatever reasons, they don't really like to be transparent with you. At some point, someone likely realized, oh, well, these other people have way more experience, so we're going to go with them. So what kind of jobs should they apply for? I'd say 0 to 2 years of experience. Jobs that... So the interview process, I have a lot of opinions about this. The interview process, of course, they are interviewing you, but you are interviewing them. It might be a little difficult to be more selective about the companies that you go work for, but ideally, the company that you're interviewing, that is interviewing you, is one that you somewhat enjoy the interview process with. Like they ask the engineers that interview you are people that you enjoy talking to. You can have an interesting conversation with them. There's different styles of interviews, so maybe they do let you flounder a little bit in the interview, but you get this kind of gut check, this gut impression of like, do I actually like this company? And I think that's something you should respect while you're interviewing. So yeah, there's a lot of extra context, but I would say 0 to 2 years, and then a company that feels good, and whatever way that means to you.
Yeah, no, that makes a lot of sense. Do you feel like, so thinking about like we're going to dive deeper into this, thinking about the different company sizes and the different types of tech teams, or if it's like a tech focused company versus a company that isn't so tech focused, but it has a tech team. Like it's not building a product, but it does have internal tooling and a website for its own internal stuff. So do you notice certain types of companies that will maybe like prioritize heavy project work, run through your implementation, right? Because like sometimes you get take-home projects, sometimes you get on-the-spot coding challenges, sometimes those challenges will creep into kind of like leak code territory, and like sometimes they just really truly want to understand, like, do you understand the quirks of JavaScript, and like try to dig into like how much should you, like what foundational knowledge do you truly have of this language or programming? Yeah. Do you find that there are commonalities with certain types of companies? And if you do, what types of companies usually challenge you in what types of ways?
Yeah, great question. So I think this is a simpler question for people that are getting into the industry. When you're more senior, then a lot more things are assumed. So if you're newer to the industry, I'd say this has actually changed in the last 5 or so years, my answer to this. Let's for simplicity, let's focus on people that are going into front end, and you can translate to whatever your stack is for the listener. So obviously algorithms, I think, are always fair game. Other interview formats, there can be some project where maybe they have you fix a bug or add a feature, or maybe they go into one of your projects that you've worked on previously and ask you to add a feature. Take homes are always likely, but I think there's some ethical implications that go into that in terms of how much time you should spend, how much time the interviewer should expect you to spend on that. And I think also those take-home challenges should only be given after you have actually spoken with someone at the company. Right, I lost my train of thought. What was the original question again?
So yeah, you were diving into sometimes people or companies would give take-home questions, and you kind of talked about the ethical concerns of it. But
the original question? Yeah.
The original question essentially was, what types of companies are going to offer what types of problems? And I think you just started with like front-end positions is kind of what we're...
Thank you.
Yeah.
Yeah, right. So, okay, great. Now I'm back up to speed. So...
I had to remember that question. I forget easily.
A lot to say. Yeah. So, right. So once again, a little simplified for people that are starting in the industry, specifically front-end engineers. Algorithms, those concepts, all fair game. And then there's ubiquitous technologies now. There are technologies that are really expected of you to know in pretty much all roles. So I would say React is one of those. NPM, Git, of course HTML, CSS. You have to use those unless you're using React Native, which diverges from that for good reasons, I imagine. So that I think that's my answer.
Okay. So for front end, I mean, I agree. HTML, CSS, JavaScript, React. I think you are. Let me get your opinion with this, because, and maybe you can kind of, you can just correct me. So I've always had, just hearing from what a lot of people say, like if you dive into aiming for a front end role, typically, HTML, CSS, JavaScript, React, and you're typically going to get tested more on like walking through implementation, maybe a take-home project. And I love what you said, like you almost need to fight for your time. And how do you do that as a new developer when you don't know how much time you should invest into it? I don't think you should be investing 5 hours into a personal project, take home, if they're not going to be paying, right? But I feel like they're mainly testing for like good fundamental knowledge of whatever the stack they're going to be hiring you for. They just want to see you build something. Like how quickly can you get up, hit the ground running, and how solid. And I think a lot of them usually assess that through your foundational knowledge with JavaScript in general. And so they'll I've heard of tons of tests, and I've been through, one or two myself, where they'll test the quirks of JavaScript. Like how well do you truly know JavaScript? And that's where I see with front end, but with back end positions, it feels, or full stack or back end positions, it feels more, there's more of a focus on data structures and algorithms. It gets a little bit more complicated with the types of coding challenges that you're going to be given. And I think that's where the huge controversy of some of the challenges that are given, it's not very clear how that's going to apply to practical skills on the job, but it just feels like more back-end focused positions are more focused on data structures and algorithms, where front end is more foundational and practical.
Yeah, that I wrote a few words so I don't forget what I'm talking about. Great point. Thank you for because this is also touching on stuff that I wanted to say previously. I want to amend or add something to that list of ubiquitous technologies. TypeScript. I think that's a fantastic tool, in my opinion, essential for any non-trivial project. If your code is difficult to type with TypeScript, it's difficult to reason about. And if it's difficult to reason about, it's bad code. So TypeScript doesn't mean that you're going to write good code, but if you're, that's my hot take. Okay. In terms of what to expect of the interview format, right, there is convergence to a degree across the companies, and right. So you were talking about these different companies that are, say, just getting into tech. So it's always fair game to ask what the interview format is going to be like, and almost always always, in my experience, they will tell you, oh, this is going to be an algorithms interview or system design or, whatever. So that can help you. Certainly ask for more context if you feel like you would need that. That is fair game. Please do that. That is super important. And then you were also talking about the quirks of JavaScript specifically, which I would say for historical reasons, there are, more of those. So, there's this influential, author, Douglas Crockford. I don't know if you heard the name before. He wrote this, book called, I think it was The Good and Bad Parts of JavaScript, which really outlined was quite prescriptive in terms of use these things in JavaScript and don't use these things. I think a lot of the stuff in that book actually has become somewhat obsolete because of the convergence around tooling that we're using, right? Linting, ESLint, Webpack, the way that we, bundle files together, functional programming, this keyword. If this keyword, the word this in JavaScript has a lot of weird behavior, but with the patterns that we use, those weird behaviors show up a lot less often. So I think, the peculiarities are shrinking in a way, but there are some that are quite common. So I don't know if you ran into this, Don, but if you have an array of numbers between 1 and 10, and you just do, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 array dot sort, it will actually give you 1, 10, 2, 3, 4, 5, 6, 7, 8, 9. And that's because it converts each number to a string before it compares, which order they should be in. So let's go into a few concepts here. So the sort function in JavaScript can take an optional comparator, a function that will take two arguments, let's call them A and B, that you can use to determine the relative order of those two arguments. So if you want A to be before B, you return a negative value in that callback. If they should be in the same place, you return 0. Otherwise, you return 1. Actually, just a negative number or 0 or a positive number. So you can customize your sorting logic. So the way to get the expected behavior for sorting numbers in JavaScript would be to pass a comparator that takes arguments A and B and returns A minus B. So that would do the sorting. Yeah, I could get into that a little. But there's some really interesting additional concepts in terms of higher order functions and stable sorting, but interest of time, we'll maybe save that for later.
Yeah, no, I mean, like I would probably find you to be very helpful. Like if you kind of ran me through some of these problems, I think the way that you describe them, I think you're very great at simplifying it in a way where you're kind of just used to breaking it down into different concepts. And I think that's what's going to be helpful to remember is like, because I'm telling you, so many people that I talk to, they're just so overwhelmed with data structures and algorithms, and they have this end goal in mind that's very unreachable, abstract, like they can't even solidify it. They don't know when the finish line is, right? And I think what you're trying to teach is like, as you're learning fundamental concepts, as you're going through coding challenges, eventually they're going to kind of blend together, and these coding challenges will give you that exposure to how these fundamental concepts can be used in a more complex manner as building blocks in more practical types of problems, right? So I love the advice that you've given, just kind of like get some exposure to these concepts, work on it every day, and then as you learn programming in general, like it kind of just seems like you're blending them together. And with that exposure, I think it's going to be easier to start solidifying kind of just like a little bit more of a linear path into data structures, more complex data structures. So I wouldn't necessarily say it's a linear path. I would say it's more of a tree or just a graph. Traverse the graph and learn what you need to learn on demand. Yeah, no, that's fair. I think that's a good correction. Thank you. But like it also kind of what we were solidifying with, it sounds like there's a huge emphasis on quirks, especially in the JavaScript world. There's a huge emphasis on quirks if you truly want to understand the language. And I would almost argue it's like some of these abstractions and the way we bundle things. I would argue companies are still trying to test if you kind of understand what's happening under the hood. I think a lot of teams understand how these bundles create these abstractions, and I think it kind of causes developers to be lazy. I feel like there are developers that do understand that I've worked with, and I find that just like even with my second interview at a company, they were really fascinated with me understanding like weird set timeout quirks and stuff like that. They wanted me to understand the language thoroughly, and I still did a React challenge, but the conversations that I had at that company were like, I remember being introduced to You Don't Know JS, which kind of started to upgrade me a little bit with my JavaScript skills, and then I just expanded from there. But anyways, what I'm trying to say is I think your emphasis on like, it seems like you kind of keep digging into like some of the quirks of JavaScript and try to break that down into like what concepts you truly need to understand. I think it's going to eventually develop a good foundation to be able to tackle some of the challenges that you're going to be facing in the interviews. That is a long-winded response, but do you feel like what I said was fairly accurate?
Yeah. Let me add a little bit more color. Okay. I have seen that there is less emphasis on the quirks with the newer hires, but of course there are quirks that do show up quite a lot. I wouldn't really call, set time behavior, weird set time out behavior quirks. I think that's actually quite instrumental to the language, to JavaScript. So JavaScript, get into a few more concepts, is a non-blocking language. So in Python or pretty much every other language, you can sleep. You can have the current thread sleep. You can say thread.sleep, for 3,000 seconds. 3,000 milliseconds, more reasonable. And then that thread will wait that long and then pick up where it left off. There is no sleep in JavaScript, and you could do just some while loop that, locks the execution. But in JavaScript and, the web, you're probably working on the UI thread, unless you're doing web workers or anything like that. That's additional complexity. But if you have some hot while loop like that, that's just waiting for 3 seconds to pass, then the page will be stuck. People don't do that. So you have to use, set timeout, set interval, and similar functions to schedule things. And I do actually really like to see a solid understanding of the event loop. There's a fantastic there's some fantastic resources around the event loop that I found. I don't have them on top of my head right now, but event loop, if that's confusing to you, then look that up in JavaScript, and I'm sure you'll find something good. That's JavaScript is one of the few languages that is non-blocking. So there's additional complexity and significance to set timeout and set interval. Yeah.
Okay. All right. Well, I appreciate how much you've really dug into some of the technical details to explain some of these concepts. I think you do a really good job at that. But anyways, I do want to be conscientious of your time. We're pretty much out of time. So, Matt, like I said, I meant when I said this, I do think if you and I had a one-on-one session, I do feel like you would be someone that would be able to be empathetic and thoroughly kind of explain things, but also help me understand the problem in a way that where your whole philosophy is okay, break this down into its concepts. What do you truly need to understand? And what are those building blocks? Let's learn those, and then we'll build up to this. Because I feel like that's kind of the way you do things, and I think that's a great strategy. But I guess I'm just kind of shouting you out a bit. But if you wanted to share anything, if people want to connect with you on social media or get further help, if they're truly stuck with data structures and algorithms or trying to get interview prep, anything like that, what would you like to share with us?
Yeah, thanks. So you can find me at Coach Matt.io. So Coach MATT.io. I do currently one-on-one sessions, and then I also do asynchronous support. So I call the one-on-one session synchronous support, and then the other one asynchronous support. I also have this platform that I've been mentioning a handful of times where you can practice algorithms, and there's this additional context and graph of concepts that you can explore. And there's some really exciting features that I'm going to be adding to that shortly. So I'm on YouTube. You'll find everything through my site. I'm going to be branching out into other social platforms, but that's all coming.
Sounds good. Well, seriously, thanks so much for coming on, Matt. In the comments, let us know what you thought. I feel like this is just an area where there's so much advice going on. So much advice given on Reddit, Twitter, and I feel like it's very, very conflicting. So I wanted to do this episode just because this could even be an intro branch into bringing other people on to talk about data structures and algorithms. But if you like this episode, let me know. If you have any questions, anything like that you want to talk in the comments, feel free to leave it there. But Matt, thank you so much for coming on.
Thank you.